This is a recording for Edexcel Further Pure 1. Vectors section 1.2, finding the vector product A cross B. In the last video we discussed how the vector product A cross B produces a vector which is at right angles to both A and B. What I want to do now is to look at how we can find the components of this vector. So here we can see the two vectors A and B written out in their component form using the unit vectors I, j and k. So in each of those vectors for A and B we've got three components, and each of those components has to be cross product with the components in the second vector. So in total we'll have 3 multiplied by 3, which of course is 9 different components or different parts to our vector product. But actually it's not too bad, because we'll see that we're going to get things like I cross I and J cross J and K cross K, and those are all equal to 0 vector because they are obviously parallel vectors that we're forming the cross product of. So the ones that we then have to look at are those where we're involving different vectors. So for example, the I component will come from J cross K and K cross J. Now if you remember from the first video, then we found that J cross K was equal to I, and therefore K cross J must be in the other direction, negative I. So let's look at that component in particular. J cross K is A2 and B3, so that's A2J crossed with B3K. Therefore we get A2 B3 in the I direction, and then we've got K and J giving us A3 B2, but that will be in minus, so we get A3 B2 in negative I direction. So this is the total component for I. In other words, if we had a big vector it would be in the first row. Now we can continue similarly looking at that, so we get this expression here. Check through, pause the video, check that you agree with these components for I, j and k. Now don't worry about having to memorize this expression. It is given to you in your formula sheet, so all you have to do is to be able to apply it. So let's look at this example here where A is the vector 1, 3, 2 and B vector 3, 4, 2. So using that expression then, A2, B3, well A2 is 3 and then we've got 2 is, so give us 6. And then we're subtracting from that A3, B2, so A3 is 2, and that's 4, so we've got 2 times 4 is 8, 6 minus 8 as the I component. Similarly, A3, B1 is 6, and we're subtracting from that A1, B3, which is 2. A1 multiplied by B2 is 4, and then minus 3 times 3 is 9. So that gives us a value of negative 2, negative 4, beg your pardon, plus 4, 5. Well, sometimes the questions are not just as simple as calculating the value, but they give you a missing component, as in this one. So it says the cross product of 3k1 with negative 204 is equal to 12, negative 14, 6, and we're asked to find the value of k. So this is just really using knowledge of, or at least being able to use this expression that you're given, remember. There are different ways of doing this, but for example we could use the first component there, which is 12, and that comes from these two multiplied together, which is A2 and B3. So that's 4k, and then minus 1 multiplied by 0, so minus 0, and that must be equal to 12. And therefore we get that k is equal to 3. We could have used really the third component as well, which would be 6. It doesn't matter really which one we use other than the 14, of course, which doesn't involve k. So if you looked at the 6, here we'd have A1 and B2, which would be 0, and then minus of negative 2k, and that would be equal to 6. So again, we get that k is equal to 3. So remember, this formula here is given to you in your formula sheet, so it is just a case of applying it in different situations. What I want to do now is look at an alternative form of the A cross B, which is using determinants. Now, you'll see that these here are very similar to the expressions that you get when evaluating a determinant. And that means that we can actually write A cross B as a determinant in this form here. Now what I'll do is just show you how that works. So remember that with a 3 by 3 determinant, then we can take the first element I there and multiply it by the determinant, which is given by that block of 4. So it's I and then A2, A3, B2, B3. The second component will be minus J and then multiplied by the determinant of columns 1 and 3. So here A1, A3, B1, B3. And finally we'll have plus K and then the determinant of the first two columns, A1, A2, B1, B2. And when you calculate that, I is multiplied by A2, B3, so the determinant here, A2, B3, minus of B2 and A3, so A3, B2, so that's the expression we've got at the top of the page. And then we've got A1, B3 for the determinant in this second little block of 4, minus A3, B1. But of course it's negative of that, so that gives us J multiplied by A3, B1 minus A1, B3. And finally, we get K multiplied by A1, B2 minus A2, B1. So indeed, this determinant of this 3 by 3 is exactly the same as this expression here. Now again, you will be given this in your formula sheet in this form here. So as long as you know how to calculate the determinant of a 3 by 3 matrix, then you can calculate the cross product in this way. The first thing to do is to write this as a determinant. So the first row of which is I, J, K, those unit vectors. The second row is the components of A, so it's 1, negative 3, 4. And the last row is the components of B, 3, 2, negative 1. And then it is just a case of calculating the values of that, so that it is I multiplied by the determinant of negative 3, 4, 2, negative 1, so that comes from this block here. Then minus J multiplied by the first and the third column, so 1, 4, 3, negative 1, and plus K multiplied by the first two, which is 1, negative 3, 3, and 2. So we now can calculate these 2 by 2 determinants. The first one is 3 minus 8, so that's negative 5, so we get negative 5i. The second one, negative 1 minus 12, so negative 13, but remember it's minus of that, so plus 13j. And finally, 2 minus negative 9, which is 11, so plus 11k. And what I'd like you to do now is to pause the video and to attempt this second question here, and then restart the video. Well, I hope you've done that, and you should have found that you get 5i minus 13j minus 11k. Now, studying that, it shouldn't really surprise you either, because if this is A cross B in the first question, then in the second part we've got B cross A. Those should all be underlined as they're vectors, and we know that A cross B is equal to negative of B cross A. Now again, remember that this here is given to you in the same way as the first expression was given to you. So it doesn't matter which of these you use. Although in some circumstances it is easier to use the determinant, and we'll see that later on in some of the later videos. Finally, it is possible that you have a calculator that does these calculations. So what I would like you to do is to, again, pause the video and just see if your calculator is capable of doing this, and come back in a few seconds when you've done that. Well, if you have got a calculator which did it, then the answer should be 21, negative 6, negative 8. It doesn't matter if your calculator doesn't, it's just a handy check if it does. That's the end of this video, and in the next one we'll be seeing how we can use the cross product to find the angle between two vectors.